Hi students, today I will teach you a new topic, haloalkanes, also known as alkyl halides, which is a topic for chapter 7.0. Firstly, I would like to introduce about haloalkanes. At the end of this subtopic, students should be able to draw structures and classify primary, secondary, and tertiary alkyl halides. Number 2, name the primary, secondary, and tertiary haloalkanes according to the IUPAC nomenclature. And number 3, describe haloalkanes as compounds that contain polar bond and the carbon bearing the halogen is susceptible to nucleophilic attack. Haloalkanes are compounds in which a halogen atom, fluorine, chlorine, bromine, or iodine replace a hydrogen atom of an alkane. The general formula of a cyclic haloalkane is CnH2n plus 1x, and the general formula of cyclic haloalkane is CnH2n minus 1x. Haloalkane, also known as alkyl halide, and the symbol of haloalkane is Rx, which is R is alkyl group and X is halogen. It is an example of alkane compound that contain one carbon atom. If we replace one of the hydrogen atom in the alkane compound with halogen X, it will become a haloalkane. Haloalkane can be classified to primary, secondary, and tertiary haloalkanes. Classification of haloalkanes are depending on the class of carbon atom linked to the halogen atom. Class of carbon atom depending on the number of alkyl or aryl group attached to that carbon atom. CH3X is the general formula of methyl halide, which is halogen is bonded to the methyl group. It is an example of methyl halide CH3Br. RCH2X is the general formula of primary haloalkane, which is halogen is bonded to the primary carbon atom. CH3CH2F is an example of primary haloalkane. It is general formula of secondary haloalkane. It is secondary haloalkane because halogen is bonded to the secondary carbon atom. The example of secondary haloalkane is CH3, CHCl, CH3. Tertiary haloalkane is when halogen is bonded to the tertiary carbon atom. The example of tertiary haloalkane is CH3, CH3Cl, CH3, which is Cl bonded to the tertiary carbon atom. The last compound is aryl halide. It is aryl halide because halogen is directly bonded to the benzene ring. The example of aryl halide is bromobenzene. Now we will learn the IUPAC nomenclature of haloalkanes. IUPAC name of haloalkanes are derived from the name of alkanes with halogen as a substituent. Let's try to give the IUPAC name of this compound. First step is determine the parent chain, which is the longest continuous carbon chain. In this compound, there are 2 carbon in the parent chain, therefore the parent name is ethane. Second step is identify the substituent group. One substituent group present in this compound, which is Cl, chloro. Thus, the IUPAC name of this compound is chloroethane. Look at the second example. Apply the same step to give the IUPAC name to this compound. The first step is determine the parent chain, which is the longest continuous carbon chain. There are 3 carbon in the parent chain of this compound, thus the parent name is propane. When haloalkane compound contain 3 or more carbon atom in the parent chain, we need to give number to the carbon atom in the parent chain to locate the position of the substituent group. We can see now bromo, Br, is located at carbon number 2. Therefore, the IUPAC name of this compound is 2-bromopropane. When the parent chain has both a halogen and alkyl substituent attached to it, number the chain from the end nearer to the first substituent, regardless whether it is halogen or alkyl substituent. Look at this compound. There are 5 carbon in the parent chain, therefore the parent name is pentane. Second step is identify the substituent group. There are 2 substituent groups. Cl is chloro and CH3 is methyl. Give number to the parent chain to locate the position of the substituent group. Number the parent chain from the end nearer to the first substituent. Therefore, number 1 starts from left-hand side of the parent chain. Chloro is located at carbon number 2. Methyl is located at carbon number 3. According to the alphabetical order, arrange the substituent group. C in the word chloro, followed by M in the word methyl. Thus, the IUPAC name is 2-chloro-3-methyl-pentane. Don't forget to write hyphen between number and word. Next example also contains 5 carbon in the parent chain. Therefore, the parent name is pentane. There are 2 substituent groups, methyl and chloro. Give number to the parent chain to locate the position of these both substituent group. Number the parent chain from the end nearer to the first substituent. Therefore, number 1 starts from left-hand side of the parent chain. Now, methyl is located at carbon number 2 and chloro is located at carbon number 3. The IUPAC name of this compound is 3-chloro-2-methyl-pentane. If 2 substituents are of equal distance from the end of the chain, number the chain from the end nearer to the substituent that has alphabetical order precedence. Look at this example. There are 5 carbon in the parent chain, therefore the parent name is pentane. 2 substituent group present, which are chloro and methyl. Look at the position of both substituent group. Chloro is located at carbon number 2 from left-hand side of the parent chain. Methyl is also located at carbon number 2 but from right-hand side of the parent chain. In this case, number the parent chain from the end nearer to the substituent that has alphabetical order precedence. We need to consider C in the word chloro first, followed by M in the word methyl. Therefore, number 1 starts from left-hand side of the parent chain. Thus, the IUPAC name of this compound is 2-chloro-4-methyl-pentane. The last example is FCH2CH2Cl. There are 2 carbon in the parent chain, thus the parent name is ethane. According to the alphabetical order, give number to the parent chain. Refer to the substituent group present, which are chloro and fluoro. We need to consider chloro first, followed by fluoro. Thus, number 1 starts from right-hand side. The IUPAC name of this compound is 1-chloro-2-fluoroethane. More information about structure of haloalkanes. The functional groups of haloalkane is halogen group. The symbol is X. CX bond in haloalkane is a polar bond because the halogen is more electronegative than carbon atom. X halogen has partially negative part and carbon that bonded with X is partially positive part. Therefore, carbon bearing the halogen is susceptible to nucleophilic attack. CX bond is the site of reaction for the chemical reaction of haloalkane. Haloalkane are reactive and undergo nucleophilic substitution reaction and elimination reaction. Please remember, what is nucleophile? Nucleophile is any negative or any neutral molecule that has at least one unshared electron pair. We will discuss more detail about chemical reaction of haloalkane in subtopic 7.2, chemical properties of haloalkanes.